It looks that I found a load of these smart meters. They were abandoned nearby, thrown over a wall. A load of stuff gets chucked over that particular wall, quite often out of stolen vans or just general waste, a load of trade rubbish, that sort of thing. Local fly tipping spot. Now, there were a lot of meters. I've sent some to Big Clive, so he will be posting a video about these at some point as well. There are details of owners on some of these meters. I've contacted the company whose name was on them and didn't get a reply from them, so I guess they're ours. So they all appear to have been serviced and packaged up, ready for installing, I guess. So let's take one apart, have a look. In the bottom we have a little conductive pad on there that goes down to some contacts to detect if that's removed. Removable. Might come in handy. Then we've got live in, neutral in the middle, and live out. Another tie on there to temper tie, stop people undoing it, or at least make it difficult to get in. On the front, of course, we've got the big LCD, infrared port. It's still got the protective tape on it. Right, take that tape off. Got a bit of steel here, so the magnetic pickup locks on, and then it lines up the infrared emitter and receiver. I imagine there's some sort of light guide going down to the main circuit board inside. The keypad, according to the instruction manual for this, that is so if the system is offline and people have paid for a top up, if they're on a pay-as-you-go energy thing and it's not working, they can enter codes, and each meter will have a set of codes, and they can type in values as described by someone over the phone, I guess, to enable credit if the thing happens to be offline. Now this top half is a modem and gateway device, really. It's got a ZigBee module in it, or probably has a ZigBee module and a 2G phone module in. 3 LEDs on the front, power, WAN, that's the GSM signal, so how it gets its connection to the internet, very low bandwidth, and then HAN, home area network, because this will tie into the little LCD displays and also the gas meters, so this will talk to the same brand of gas meter. So let's get that off, have a quick look. Right, so in this top unit we've got GSM aerial connector, a SIM slot, generic white SIM in it. There are a few networks that do like really cheap data only low bandwidth 2G stuff. Now there's another one of these little rubber contacts, so that sits down on the top of the meter just there, so the meter can detect if this is removed. Um, 10-pin communication header. A couple of extra points here, not sure what they're for. Looks like there might be more conductive pads could fit in there for something. There we go then. That's a button on the front. So we've got the 3 LEDs with little light guides out the back, and a button, little conductive pad on the back. Which goes down to a thing marked switch 1 here. Right then, so on here we have the Sierra Wireless module that looks like the GSM. Turn it around so the writing is the right way up. Air Prime. Now, my video laptop has just told me the battery's flat, which is odd because it's plugged in. Okay, sorry, my laptop shut down, so I'm going to try using the Chromebook for recording video now. So having a look at this thing, we have the Sierra Wireless Air Prime SL6087. It has its EMEI printed really small just there. It's not going to focus. The main processor, we have an ARM STM 32F101 RGT6 in the middle there. There's an off-board GSM aerial. It's quite nice. Dual band? Little dual band dipole. Handy. Let's see how it's possibly power supply down here. And here we've got some 25 series memory. So 25 PC16v6. An ST part, that's a microchip part. $23K. Need an scope on that, sorry. $23K 2561 SN. Not entirely sure what that one is. And another 25 series memory chip there. Resonator, crystal. .0592 megahertz. and a ZigBee module. These are used for communicating with the in-house displays and the gas meter. What holds this in? Plastic clips. So this side we've got SIM socket. Looks like space for a battery over here. A couple of terminals. Do they line up with the holes? Now there's nothing that lines up with those two holes, so I guess that must be for a different board. Some space for some extra parts. Two huge capacitors. 50 farad. Very nice. I'll have some of those. High power resistor. Oh yeah, nice headers and RF connector there. That might be useful. Capacitors definitely useful. And possibly that ZigBee style thing. Yeah. Might look into that a bit more in another video. So, back to this main meter. Should we see what it does when it's turned on? So we need a anti-tamper contact in there. Some tape. It's got no SIM in it, so it can't phone home. Put another anti-tamper pad on there. Okay, so I've got this hooked up now to a bench 240 volt supply, 240 volts AC, not the mains. Let's turn it on. Right, I can hear a switch mode power supply in there. It's charging the capacitor up. Not used. Wait. So 0 says wait. Vend mode. Rejected. As if 01 isn't a good code. Right. So not very interesting. It's showing us that the power's on. Kilowatts, 12 megawatt hours on there. Cover open. Oh. Right, it's spotted that one of the covers is removed. Oh, commission menu. Enter MPAN. Yeah. Okay. Test switch. Yes. Press A. That was a very big clunk for a relay. And on, another big clunk. Test passed. No one set. That's fine, we don't have one. Okay, let's take this apart. Get out. Right, another tag. These are all ferrules, you say. You say small on them, SML. I expect to see current transformer, big relay, power supply, and don't know what else. Hidden screw. Very long hidden screw. Okay, so under here, it's nice. The light guide for the infrared. Got a nice little rubber boot on it. Another security switch. It goes down to the board there. And regular keypad. Rubbery. So, what do we have here? Plastic cover that just pops off and doesn't show us anything else really. So, we got in, neutral out. Oh, it says there's a shunt. LCD, we've already seen, does simple text. It's got an LED backlight. Nice. It's a little LED. Okay, so I can see right through this. So it's an LED at the end, shining along. And there's reflective tape around the outsides, just to shine the light back in. fairly standard. Nothing under there. So how does this come out? Yeah, it just lifts out, I think. Oh, maybe not. Oh. Open! Doesn't want to. I have to end the video here, it's not playing. Is it glued? Is it a screw? Ah, there's a plastic. Haha, sneaky. There's a plastic clip hanging onto a component. There we go. What's that doing? What's that? Aha! That clip grabs onto the relay. Right, so nothing in there. A nice groove to direct water around. No seal, unless it's on the front panel. No seal, just a groove to direct water away from it. Now at the bottom, little drip holes. So, what we got? Right, big old switch, big capacitors, a can, little capacitors, a battery, half AA battery, squeaker, H3, that looks like it's marked AB. I wonder if that's a temperature sensor or... Oh, it's actually got 3 connections, one on the bottom, and one on each side on the top. So I wonder if that's a Hall effect device to detect tampering. A big can, Shield 1, TX1. So, some sort of power supply. Big switch. 24 volts. Let's have a closer look. So there's, on the side here, there's 3 terminals for the coil, and it says 24 volts, 105 ohm, 105 ohm. So it's got 2 coils, and it's rated to 100 amps at 250 volts AC. Very nice. So the supply comes in here, into the switch. Is that right? No, it comes in this side. In this side, through the shunt, which is just in here, I think is laser trimmed. or certainly trimmed. I think that's still a copper. Is it something else welded in? It's hard to tell. Destructive test. Yeah, it's not copper. So that's some other material between the copper. But what that is. Yeah, magnet doesn't stick. Maybe it's aluminium. Right. So there's a shunt. We've got measuring points either side of it. Mauve. Looks like the mauve is between neutral and phase in. Neutral resistor up to an inductor, and the diodes down here. So it looks like the power for the device itself goes through that resistor, and this is phase in, and all of this, all this copper here is on phase in. We've got a gap capacitor opto-isolator. It's interesting. So this is all reference to live. Then we've got a micro under there. Under there, look. Right, let's have a look at this contactor switch relay jobby. Open! Show me your secrets. With the springs. No springs. Oh, that's quite nice. So in here we've got these huge contacts, 2 of them, coils, there's a magnet somewhere. I think there's a magnet inside here. It's missing its top pivot. I'll just mash that up. Right, so that's in the on state. Then hopefully push that side up, pull that side down. See, that's in it. Should be in the off state. I've broken it, this, haven't I? That's how it's supposed to be. Look. So the electromagnet causes this thing here to pivot, which is attached to this arm that pulls the contacts back. So power goes off while it's disconnected, it stays disconnected. Clever. There it is in the on state, contacts closed. Nice. See if we can get this off the board. Could get a soldering iron on it. It'll take a lot of heat to get that off there. Can't quite get the snips in. There we go. Mighty big contacts. Very nice. Just sneak that mob out of the way. That's IF9 P680L 100C. So here's the shunt. It looks like it might be something welded in, or it might just have been treated with something that's left it shiny. I don't know. Interesting. .50 volt 1000 mic. I would normally take more care about dismantling something, but it's for science. What are you? Oh, the writing's come off with the sticker. Texas 47 EA 6KT G4 MSP 430. There we have a row of opto isolators. So that's how the meter and the modem communicate, I guess. 10-volt 1000 mic. See if we can get the can off. Okay, so removing the can didn't reveal much. Look those numbers up. No, nothing new. Well, there we have it. What used to be a smart meter.